prkpndy and I have built Aegis, which is your shield for private Zcash transactions. The problem that we are trying to solve is that building shielded Zcash transaction is hard. It requires deep cryptographic knowledge and complex zk proof generation, and there are no simple libraries for generation for developers to build upon. As a result of which, privacy features on Zcash remains vastly underutilized. The solution is Aegis, where we have made sending UTXOs from your transparent account to a shielded account as simple as writing a single line of code. So to understand the solution, first we'll need to understand what is PCZT. It stands for partially constructed Zcash transaction. It's modular, it's secure by design, and it follows industry standard. These are the core features of our application. Coming to the architecture, we follow the PCZT specified architecture, where we first propose the transaction using the creator role, then we generate the zk proof, we sign the inputs, and then we extract the transaction bytes and send it to the node. We have cross-language support in our application. We have the Rust core library, on top of which we added the FFI layer, and then we added the Go bindings for illustration. We can easily add Python, JavaScript, TypeScript, Swift, Java, or any other language on top of this. So it has vast amount of real world use cases. We can use it in privacy wallets, for payment processors, DeFi applications, cross-border payments. Everyone can use it. So what we have built a complete Rust library following the PCZT specifications. On top of it, we have added Go FFI bindings, we have working examples, comprehensive documentation, and script for testing, completely end-to-end on testnet. Now I'll show you how to test it. So I have added testing guide in the repository itself. So first we'll generate the transparent address using this command. I've already run this command, and I've got the address and the private key. Then we'll need to create a .env file where we'll add these addresses. I have already added my transparent address and private key here. Then we'll need to add some tokens to this address. I'll go here and click this. It will do some proof of work. I've already sent some tokens. As you can see, I have received it here. This I ran previously. I'll go to the transaction, and here I can go to the JSON where I'll get all the details of the transaction. Okay, so the second step would be that I'll need to generate the shielded addresses. I'll run this command. Cool. So I've gotten my unified address. I'll copy this and paste it in the destination address env. So here is my transaction ID. Where is my transaction? Okay, here is my transaction ID. I'll paste it here, and I'll need my this as well. Cool. I've also added the RPC URL for the node, and I've also added the API key for this node. You will need to add your own API key. I've already added it to my terminal so that I don't have to show it here. Then I'll run this command, which will transfer the amount from my address to the shielded address. It'll take some time. Okay, cool. So we have the transaction ID here. We can view it on the Explorer as well. Here it is. You can see the JSON as well. We have the transaction ID somewhere here. Yeah, here is the transaction ID, and other details are present here. You can also do the same using the Go library. Okay, yeah. So I'll just copy this and use So we demonstrated it with the Go library as well. You can see it on the Explorer as well.